Hello and welcome to this tech video for my Unity Indie Games project. The aim of this video essay is to explain to you my goals for this project, how all the tech works behind the scenes, and what I've learned from this experience. This project was my chance to create my first fully finished and published indie game by myself with my own assets. So at the start of the project, I set myself three basic objectives to follow. First of all, the design objective. Make a publishable puzzle platformer game where the player must use gravity to progress through the levels. I should have about 20 levels between 4 zones with different styles, difficulty and mechanics. Secondly was my artistic objective, which is to create and implement a custom skeletal animated player, create art assets for all 20 levels and 4 zones, UI on top and anything else I needed along the way. And finally, my technical objective was to use industry standard design patterns such as singletons, object pools, interfaces, and events to create a more optimized and stable game, and also just for practice and my own growth so that in the future, when I potentially get into industry, I know how to use these things. I also had to use these things to be able to create puzzles using buttons and doors, power, through scripting functionality. So you know my objectives now, but how far did I get? Well, I ended up completing all 20 levels and splitting them between 4 zones, each with different puzzles, mechanics, artwork, and music and sound. I also completed all the menu systems that a standard game would have, such as settings and keybinds, and I was even able to get a lot of general polish off, such as shaders and even a splash screen. But you're probably wondering how it all works, so let's jump right in. The player controller is largely controlled by this player controller script, and as it's the only character in the game, this script holds all the information the player needs, such as like movement speed, jump height, and then all the booleans for working out if they can move, and things like that too. It also holds public references to the player's ragdoll, the player's GFX, which is like the parent to the skeletal mesh that is the player, as well as the grav gun that's on the player's back. In the awake function, we not only get the rigid body, but the animator and all of the input keys the player will need to be able to move around. And then in the start function, we grab a reference to the audio manager. This is so we can play sounds like footsteps or jump grunts. The update function is where this script will do most of its work. What it's doing here is checking for input keys for left, right, and then also for the jump and interact key. The first two are self-explanatory. If they press the left or right key, moving is set to 1 or -1, -1 being left and 1 being right. Is moving is set to true. This is used by the player controller so it can play footstep sounds. Then we set a float in the animator to let the animator know that we're moving at a certain speed. This will activate the walking animation for the player. We also get the world point for the mouse position. This is so that we can aim the grav gun. One other thing we need to do is check if the player is grounded. This is not only important for the animation, but also to make sure the player doesn't double jump and can't just instantly jump into the sky. And then if they're not grounded, we set the falling animation and also add to the airtime so that the gravity scale is increased, which means that they'll fall faster the longer they're in the air. The jump input is self-explanatory, similar to moving left or right. You check for the jump key, and then if it's pressed, you check if they can jump, and then if so, add force to the player and play the player jump sound. If the player hits the interact key, the player controller checks if there's any button in range, and then if there is, activates the button. You may have noticed though that we didn't actually move the player at all, and that's because this is all done in fixed update, which is called exactly at 60 times a second, while update it depends on the frame rate of the actual game. So in fixed update, we first check if the player is alive and can move. This is not only to make sure they can't move when they're dead, but also means that they can't move when they're inside of a cutscene, or there's dialogue prompts, etc. So first, we got to make sure that the player walk sound is playing. So this is just a few if statements to make sure that it's not playing while they're in the air and that it's playing only when they move. This is also where we check if they're grounded, and this will be an overlap circle on a ground checker's position, and then using a what is ground layer mask. Because the player can walk on every single wall or ceiling, we need to make sure that depending on the rotation of the gravity, we need to move the player different directions. Otherwise, if you hit left, you would end up moving right when on the ceiling. This can be messed up a bit when there's cameras that are rotated, but I've left that as how it is because I felt it added to the puzzle experience. But this is basically what we do. We take a switch statement on the grav rotation, and then depending on the case, 0 being regular gravity, 3 being on the right wall. After we start moving the player, we need to make sure that they're facing the right way. So we use a similar thing. If they're facing right and the move input is above a certain amount, we flip. After that, we also need to quickly change the weld point of the grav gun to make sure it's facing the right way. And then before we work out the rotation of the grav gun, because we would want to point it towards the player's mouse, we need to make sure that we're using the right calculations, because obviously if the player is on the ceiling, then we're going to get the opposite of where the player is supposed to be aiming if we use like the player's rotation. So we check here if the grav rotation is equal to 2, which would be on the ceiling, and they're not facing right, or they are facing right, then we negate these, and then here we work out the rotation that the gravity gun should be facing. And then we use the slurp command to move it over time. We've already had a look at what the flip function does. This is just for rotating the player around. We do this by just inverting the scale of the player. Rotating the player on the z-axis in a 2D game can work, but it leads to some weird visual errors, especially when you're working with the rotation of the player anyway with gravity. There is also the kill player function, and this can be called by a few things. If the player falls out of the world, gets hit by an object, then this calls, and then it leaves a debug log for now telling us how the player ended up dying. All this basically does is disables the GFX of the player, enables a ragdoll for the player, and then sets the grav gun to false so it can't be used. There is also the disable player and enable player function in here, and this is called from outside the script by other things like the level manager, and it's basically used to disable player abilities like movement or gravity or grav gun, or just pause the player entirely during like cutscenes or dialogue. The rotate gravity script is another script attached to the player character. It's called and used when the world gravity needs to change. It also sets itself an input key using player press, and then all it basically does is in the update function it checks for this input key. If it's pressed and the player can actually rotate gravity so the cooldown isn't on or it hasn't been disabled by a level manager and they're alive, then it gets the grav direction, activates the cooldown on the player HUD, and then plays a gravity burst sound effect so the player knows what's happened, and then it starts the timer. All the called function basically does is a switch statement, checks the gravity direction, and then depending on the current gravity direction, will then set a new one. So if it's 0, set it to 1, if it's 1, set it to 2, etc. And then also change the physics gravity, which is the world gravity, to the new gravity. Then all it will do is rotate the character, which is just another switch statement. Same thing basically. All this is doing is just setting the rotation of the character and then setting a var for the character so it knows what the grav rotation is. And it will come back here and then just call a game events. What this game event basically does is just tells every object in the scene that the gravity is rotated. This is so that they can also change their rotation and then also activate a shader script. The gravity gun script is a very large script attached to the gravity gun. It basically handles everything from shader effects to creating the line renderer to actually changing the gravity of objects. As you can see here, we've got lots of public settings like the uses, which I don't currently use, but it's effective. So if you wanted to create a level where you could only use the gravity gun like 3 times, then you can set that. And then it's got the range, the cooldown, the layer mask, which is basically what the raycast can actually hit. So we'll go through the player object references that the gun needs to function, and then some private vars. It also has an input key. In the awake function, we'll get the audio manager ref, and then we need to do 2 things before we can start using the laser. First, we need to call fill lists. This is basically to fill a list with all the visual effects that we'll be using with it. And then we need to disable the laser immediately. The fill list function is pretty simple. Just have 2 for loops here that check for the child count of parent game objects, and then if there's any particle effects in there, just add them to a list. Same with the disable laser function. Basically just disables the laser, make sure no audio is playing, and make sure all visual effects are off. In the update function, we have to individually check for the grav gun down, if it's just been pressed, and then if it's gone up. So if the key is pressed down, then we need to enable the laser. If the key is then continually held down, we update the laser, almost like its own update function, and then if the key goes up, we then disable the laser. The fixed update function is just used for the cooldown of the laser. The enable laser function is just the opposite of the disable one. Enable the line renderer, make sure audio playing effects are on. In the update laser function, we have quite a bit to do. First, we need to make sure that the cooldown timer is 0, so that we're not using the laser when we can't use it. Then we need to get the mouse position as a vector 2 in the world, and we need to first of all set the line renderer's position to be the fire point, and then set the end of the line renderer to our mouse position. Then we get the direction of the laser using the mouse position and the transform the gun, and with that direction we call 2 raycasts, one called hit and one called hit object. The first raycast is used just to make sure that the line render keeps going and will stop if it hits an object that it can't affect. And then the hit object raycast, it check and find objects that it hits, see if they're the correct object, and then change their gravity. So first we will check a tag like free object or pinned object. We then make sure that it's being called once. Then we get a reference to the object through the collider that the raycast hit. We activate the cooldown on the player HUD, and then we grab an interface off the hit object, which every single object with these tags will have, and through that interface we call a function called onShotByGun. We'll get to that one later. The last thing we need to do is use an object pool to spawn from the pool a little gravity burst effect. Then we set the cooldown timer, set it to be charging up, and then we start a coroutine to delay the laser to stop a visual effect from happening. At the end of this update function, we also need to set the end position transform of the line renderer. We also need to set the end VFX transform position at the end of the line renderer. While we're here, we might as well mention how the player HUD activates cooldowns and then shows a little visual effect. You can see here, you get the player HUD and activate a trigger in the player HUD animator called activate cooldown. You set that to true, that when that's set to true, we go from the idle position into the cooldown icon, and then when that's done, we go back into the idle position. All free and pinned objects, including some other things like a battery, will have this script called the gravity shader script on. This script is basically responsible for activating visual effects when they rotate, and then also if they get shot by a gun. So we need a reference to the material. There's a shader material I made that basically has a bool in it that you can chain. On the start function, we'll assign any private variables that we have, like the rigid body and material, and then we'll subscribe an event called onGravityChange to the game events. This links it to that game event we saw earlier in the gravity gun script, and basically means that whenever that's called, this function here gets called on every single object that has this script. All this script does is sets isActive to true, and then we'll set the int isActive, which is basically like setting a bool in a shader graph, to 1, which is the equivalent of true. Once this happens, the visual effect will activate, and then the fade timer will slowly go down, and then once that fade timer reaches 0, onFadeM will get called, which will set the int to 0, meaning the effect no longer happens, and will set isActive to false. The last part of this whole mechanic is the object pool, which holds the visual effects that need to be spawned around the place for every single object that is changed by gravity. An object pool is basically a pool of deactivated objects, and then when we want one, we just change the location of one of these objects and then set it to be active. And this is much more efficient than spawning in and then destroying an object every single time. To do this, I first made a class called pool. It needs a tag, a prefab of the game object it's going to be pooling, and then the size. Then we need a list of the pools and a dictionary of the pool. In the start function, we're basically going to go through every single pool that we have and set game objects for them. We first instantiate them and then set them to be not active. And then we add that pool to the dictionary. It's basically going to have multiple pools of different objects. And then when we want one, we go to the pool, we specify the pool through the tag, and then spawn an object in. To spawn a game object from the pool, we need the tag, the position, and the rotation of where we want it. And then we'll return the game object as well, so that whatever function called it can then use it. So first we check if the pool dictionary contains a tag. Doesn't, then it will return saying it doesn't exist and return null. Does so, then it'll go on game object to spawn, find the tag, and dequeue the object. It will then set the object to true, change the transform position and rotation, and then call a function which is basically a start function through interface on every pooled object, called object to spawn. Then if the spawned object isn't null, it will call that interface function, enqueue the object, and then return the spawned object to whatever function called it. The next thing we have to talk about are doors, buttons, and power boxes, the main puzzle parts of this game. So there's a few things that you can change here, like if it's already open, and then more settings on the buttons that will be attached to them. Start is the same as most, we get the Audio Manager instance, and then if it's open, we change the color of the light. The rest of these functions are called by other scripts like the button script. All these basically do is open door and close door. We'll just start a coroutine and change the transform position of the door GFX to the new one, and then also set the open if it's true or false, along with the color as well. And then here we have the two enumerators that are used to move the doors. We've got the hold door function, which just holds it, and then the move to position one, which just moves the door over time and also plays a door sound effect as well. The lock door function is basically used by blue buttons, and it will just change door held in position to true, which means that it can't change position. And this is checked earlier in the script, when we want to close the door, we first check if it's held invisible or not. The button script is a bit bigger. Again, it just has all the options, all the buttons. You could change the button to be one-time use, or if it's already on, if it's going to hold the door in position, sound effect name that the button will make, and then up here we've got two lists to basically just all the doors that the button's going to affect. On awake and start, we're basically just setting the color lights of the button, and then we first need to get the player controller reference and the script reference to this actual script. Each button has a collider, and on the trigger enter and exit of that collider, we basically just check if the object was a player using the tag system, and then if it was a player, then we get the player CT ref, we change button and range to this script here, player near to true, and this basically means that the player, if they hit the interact key, that script can call this button script and open the doors. The activate button script is what will be called by the player. All this will basically do is play the sound effect name through the audio manager, and then just check the settings on the button, like if it's going to hold the door in position, so then it will lock all the doors in this script. So then it will lock the door in the script, and blue buttons only affect one door anyway. And then if not, then we're going to go through the entire list of doors, and we're basically just going to check if they're open, then we want to close them, and if they're closed, then we want to open them. And then we check if it's one-time use, because if it's one-time use, we need to set it to off to change the button color to red to show that it's off. The final piece of the puzzle is the power box script. In this script, we need a list of the buttons and lights to power when the power box is activated, and then also just a reference to the battery graphics that we're going to use to replace the battery. So like a button, the power box has a collider on it, and when something enters that collider, to check if that is a battery using a tag. If that is a battery, then we're going to destroy that game object using the collision, and we're going to set the battery GFX to true, and this will basically look like the battery's been slotted. Once that's happened, then we need to go through the buttons to power and lights to power list. We've just got to loop through them and power all of them basically. And then this function here is a very rarely used function. It's basically just to disable something once the power box has been activated. I just used it in the tutorial scene so that a dialog prompt can disappear if the player's already activated a power box. Wind is used in some later levels, especially in the skyscraper levels, so I just wanted to go through this script and show how it works. First, a few public things. We can change the wind power and also the wind direction, -1 obviously being left and 1 being right, and then the wind power is how much force the wind actually has. In the awake function, we basically just want to create a wind vector 2 using the direction and the wind power, and the wind is always going to be on the x-axis, so we don't need to put anything in the right axis. Then on start, we get the audio manager reference because we're going to need to change volume here. And then similar to a button, we have an on trigger exit and enter for the collider. We check first if the tag matches anything that the wind should be able to affect, like a player or a pinned object. And then basically all we do is we add that game object from the collision to an array, which will basically be moving everything in that array. And then we got to know if the collision tag did equal a player, then we want to change the volume of the heavy wind sound effect up. The exit function is basically the same. We check if it's a player, and if it is a player, we want to change the heavy wind volume down and also remove the object from the array. Then in a fixed update, we're going to for each loop for every rigid body in the object array, and then RB add force wind. Now, how does the level actually work? Well, the level manager script is attached to a game object in every single level and will basically handle everything. So we've got a few public things to set here, such as level 9, if it's a cutscene or not, the animated transition time, if we want to play music theme or any ambience throughout the level, and then the player controller reference if we have it in the world. And then there's some more settings here, like if we want to disable the player on startup, disable gravity on startup if we want a level where we don't want to use the gravity, and then like a specific next level name if we want to load to like a cutscene instead of just going to the next level. In the awake, we also just want to set the world gravity, the normal gravity. This is basically just to make sure if the player like finished another level while upside down, they won't enter the next level still upside down. In start, we're going to get the audio manager reference, and then we're going to check if we can play any level music or level ambience through the names here, and if they equal none, which they are by default, then we don't play anything. and then we check if it's not a cutscene and the player exists, then we're just going to disable the player inputs back up here. So if you leave these all as false, then the player will be fine and will get disabled. These are basically copies of the disable player and enable player functions in the player. They're just here so they can be called by other scripts that don't have references to the player. Now while this is all going on, we also have the animator attached level manager, and this will basically start a crossfade when the level starts. So on entry, the crossfade ends, which means it wipes away and you get to see the full screen. And then when the level is completed, we'll get this transition call, which is the crossfade start, which will just put the thing to a black screen. So how does the level end? Well, you may have noticed an exit sign at the end of every single level. Basically attached to that is a collider, and also this script attached to the object. And all this will basically do is, on trigger enter, we check if it's the player, and if it is the player, we need to get the game time from the HUD, and then use that to work out how many stars the player has got from completing the level. Now, the time trials can be inputted as a public variable here, and then once we've got the stars, we need to go back to Level Manager and call complete level, and then also the UI Manager to activate the next level screen. Back in the Level Manager, at the complete level function, we first need to disable the player, and then we need to stop any music that was playing on the level. We're going to then use player prefs to set the amount of levels the player has unlocked up by 1, so they can unlock the next level. And then we're going to set complete to true, so anything that shouldn't be happening when the level is complete then stops happening. The UI Manager also just got called, which is going to activate the next level canvas, and in turn this script as well. Basically the point of this script is just to show the stars in an animation when they appear. So we need to know how many stars were gained, and then we need to play some sound effects for the completed sound, and then we start a coroutine, which will basically is just a tween for displaying these stars in an animation like style. So we just for loop the stars, and then depending on how many we get, we just set the trigger, activate star for the animator, wait a bit of time, and then we'll do the next one if they ended up getting any. Next, we're going to have a quick look at the UI Manager, and this is going to handle all the canvases such as the death and next level and pause canvas, and then all the buttons on top of that. So first of all, we got public references to each canvas, and then also the level manager as well, because we need that. The UI Manager is also a singleton, so we have a singleton design pattern set up here, and then we also need the pause key code. And then in update, we're going to check for escape, because that will always be a way to pause, or the pause key, or if the level manager is complete. And if this happens, then we're going to change pause to its inverse, and then if it is pause, activate the menu, and then if not, deactivate. We also check then if the player is alive, and if they're not alive, then we've got to activate the death screen and set the player HUD to unactive. The rest of the functions here are all public functions that are called by buttons on all the canvases. We have main menu here for any main menu button, and this is just going to load the scene index 0, which will always be the main menu. Quick game, which is self-explanatory. Respawn, which will just reload the scene. Next level, which is going to get the scene manager and then check the build index. Just add 1 to the build index, and we go to the next level. Restart level is basically the same as respawn. And then this function, which is going to call the next level canvas script and start the star animation, which we just saw. Now to have a look at all the menus. The main menu, levels menu, and settings menu are all a bit similar, but they each have their own things which make the different scripts. So the main menu has a script called the main menu manager on its canvas, and this will basically just handle any button on the main menu. In the awake function, first what we need to do is check if it's the player's first load, and then if it is, we're going to set the volume down just to stop that unnecessary massive spike in volume when the player first opens up a game. Like usual, in start we get the audio manager, and then we're going to check if the menu theme's already playing in case we're going back to the main menu, and then if not, we're going to play the menu theme. If the player hits play, we want to play from start, so we get the last unlocked level, and then we play from there. The rest of these are called by the other buttons, like level selection, which is just going to open the level select menu, quick game, which is quick game. Settings, we'll go to the settings menu, and then the rest down here is for loading levels. This coroutine is called a loading level to activate a transition, and then after the transition is done, through the transition time, we'll then load to the next level. Just in case somehow the player loads a scene count larger than the build settings, we just want to go over to the thanks scene, which is basically just the default. We're going to see these two functions a lot through the menus. Basically, if you want to load a scene via the name with just the string input, we need to use these two. So first we're going to need the scene name through a string input, and then through a for loop we're going to check every single scene through the build index in the for loop if the tested scene is equal to the scene name. If so, then return that tested scene. To get the name from the tested scene, we call another function which just gets the name from the index. Using the index from the for loop, we're going to get the path of the scene name and then take away the other things like slashes and dots that we don't need in the name. And then we're going to return the substring, which will be the scene name. The level select menu has everything we need to skip between levels and see our score. So obviously we have a list of all the buttons and then the list of all the lock signs, as well as public references to each background, and then the go left and go right button. So what we actually do in the awake function is we get the amount of levels unlocked through player prefs, and then using this use a for loop to check which buttons need to be unlocked through the levels unlocked. And basically what we do is we get the button, we make sure that they're not interactable if they're not unlocked, and we also set a locked sign on top of the level button to be true if the level is unlocked. Then we get Audio Manager and Start, and this can be used later. So to change the viewed zone, which is basically just moving left and right with the buttons, we use a switch statement and we check the current zone, and then depending on the current zone we're going to just change the background, set them to active or inactive. But we also need to make sure we're not going to move left or right when the current zone wouldn't allow us to. So we have this at the start of the switch statements. This is called by the cheat button, and this is basically going to unlock all levels for the player and then reload the scene so it shows all of them. To load levels, again, we're using the same scene index from name thing. This is so that we can get the scene name from the levels button and then load it based off that, which is also great because it means that if I end up adding more menu levels or other levels and the build index change, it doesn't matter, because with CNET, the scene name will still stay the same and we can still load it. We also have this main menu function for the back button, which is just going to play the accept button sound and then load us back to the main menu. This load level coroutine here is again just used to start the transition and then actually change the level once the transition is over. The settings menu houses all of the options for the game, so we have a lot of public references here to all the different toggles and sliders and panels that we need to change settings in. In the awake we need to use player prefs to get some already changed settings, just so we can change the visuals of toggles to what they were previously set as. In the start function, after getting the Audio Manager reference, I'm just going to set the mixer volumes to the saved values and then do the same for these as well. For the resolution, we're just going to get the screen of the PC and then set the resolution to just be the current resolution of the screen. To get the rest of the options, then we're just going to put all the options into a string list and then use a for loop to go through the resolutions and add them one by one to the option. Once we do that, we add options using this list that we just made. We set the drop down's current value to the current res index, and then we need to refresh the shown value. All of these are then public functions for sliders, such as setting master volume and setting music volume, and this is just going to change the player prefs and then the actual mixers float for the actual volume. We'll get into the Audio Manager later, but these mixers are basically just options on every single audio file that you can change for what mixer they belong to. More of the same here, just public functions that the drop downs can use to change the screen or quality level, as well as if the player can skip text, and we'll have a look at this as well when we get onto the Dialog Manager. To open and close the Keybinds menu, we're just setting active and inactive a bunch of panels, and then the same enumerator here, load level, is used to set an animation trigger and then load the level after. Onto the Keybinds menu, which is in the settings scene. I would have preferred to use the new Unity input system, but unfortunately I just didn't have time to refactor everything, so I ended up making my own custom input system using player prefs. First we need a bunch of public references to all the text that we're going to be changing, as well as private key codes, which are just the key codes for each input. On the awake, we're going to get all the current key codes that we have saved. and then change the text and all the buttons to those current key codes. On update, if we are checking for an input, we're gonna, on the update function, if we are checking, we're gonna for each loop pressed key in the system enum values for code. And then if we do end up getting an input of pressed key, we're gonna change checking to false so we don't get any more. And then we're gonna change keybind pressed key. This is the public function called by all the buttons that will allow us to check for an input. Basically, all this does is just change checking to true, and then uses the text mesh pro input of the text that was clicked on to then change that text later. So if we end up calling change keybind from the update function, then what we're going to want to do is we're going to get the current key codes in an array here, and then we're going to for each loop through them and make sure that the new key pressed isn't the same as any of the current keys, because we wouldn't want to have the pause and move left key be the same. And then if it is, we're going to play a little deny button sound and return false so we get out of that. If it isn't though, we'll play a little bell sound to show that it worked, and then we'll get on to actually changing the key code. So we're going to change the display text to the new key code as a string to show that that's the new key code they have. Using this, we're going to then switch through all the possible key codes, and then once we find it, we're going to then change the saved key in player prefs. And we're going to break out that and return true. Now we've seen Audio Manager being called a lot as a singleton, but we haven't actually seen how it works. So this Audio Manager is based off Bracky's simple Audio Manager, but it's been refactored to suit my game. So first of all, we need to make a public sound class, and this sound is basically going to have all of these options in it. So there's a source, and then the clip, volume, pitch, loop, and output. And the output is basically that audio mixer we saw earlier, and it's just gonna, so if you have music, you set it to the mixer group, and then you can individually change the music volume in the settings. Play and stop functions are quite simple really. We're just gonna loop through all the sounds in the array, and then if the sound name matches one that's found, then we're gonna play the sound. Also, if the fade in all is set to true, then we're going to want to fade the audio. If a sound name isn't found though, then we're just going to return out of the function and then print a little debug here saying the sound name can be found. And then that's the end of what I got from the Bracky's Simple Sound Manager. So here's the fade audio function. Basically this is called, and then if the bool fade in is true, then we're going to start a coroutine to change the volume over time. And then if it's not true, then we're going to want to fade out, so we just call the same thing but with different inputs so we can fade out the audio. Check if playing is sometimes called by things like the main menu manager or like player footsteps. It just basically checks if there's a sound name that is currently playing and then returns that so that whatever function called it ends up knowing. Pause sounds can be used to pause every single sound. That's good for like the pause menu, and then unpause all those sounds. This is the change volume function. It's called by like the win script, and it can be used to change the volume of a currently playing sound clip. And you can also choose to do it over time in the inputs, and if it is over time, then it will play the coroutine instead for changing the volume over time. If not though, then we just loop through, we find the sound, and then if there is one sound, then we change the volume of that sound. And then for the coroutine, it's basically the same as the function. We're doing it in a coroutine so that we can do it over time, and we're just going to use the lerp function to change the current volume over time and then set that to be the source volume. So this is the Dialog Manager script. It's again in every single level, and it's used to play the dialogue. So first we have a bunch of public options here. Make it so the player can't move or can't use their gravity gun while the dialogue is playing. We can also specify if it's in a cutscene or if we want to do something once the dialogue is done. First we need to use player prefs to check if the can skip text has been set to true, and you can change that in the settings. And then we're going to get the audio manager, and if play on start is true, then we're going to open the dialog with some starting sentences. So the open and dialog and close dialog functions are basically called by other things to start or stop dialog. Opening dialog is going to need an input of new sentences to play, and this has to be a list because obviously if you want more than one sentence, then you need a list. So then when we start dialog, we're going to want to check if the player is there, because if the player is there, we're going to want to disable the player based on the input settings here. And then after that, we set the dialog canvas to true. And then if we cannot skip text, then we're going to start the coroutine type, which is going to slowly type out each letter in the sentence. If we can skip text, then we're just going to want to set the text display to the sentence immediately. The close dialog function is basically the opposite of that. It's just going to re-enable player movement and stuff. Set the index back to 0, so if we have more dialogue, then the index is 0 again. And then if it is a cutscene and we want to trigger once done, then we're going to trigger the cutscene after the dialogue is done. This type coroutine is what we use to display each sentence. It's just going to for each loop through every letter in the sentence and then add that letter to the text display and then wait a very small amount of time, like 0.005 seconds, and then do the next letter in the sentence. Once that's done, the sentence will just sit there in the little canvas box. So to continue the sentence, we're going to need an input from the player. So basically what we're doing here is this will be called by the button that overlays over the canvas that displays the text. And first we want to check if the text is fully displayed, if the sentence is finished. And then if it is, then we're going to go on to the next sentence. If it isn't, but we can skip text, then that's okay. We're just going to continue the sentence. We're going to put the index along and then instantly display the next sentence. And if there isn't another sentence, then we're just going to close the dialog and end. If we can't skip text, however, and we've got to go to the next sentence, then what we're going to do is we're just going to put the index along, wipe the text clean, and then start the coroutine for typing again. If there isn't any more text to display, then we're going to close dialog. I also need to talk about how the art for the game was created and implemented, as well as the music. All of my art assets were hand-drawn in an app called Procreate for the iPad, using an Apple Pen. And then I used Photoshop for any touch-ups that were limited by Procreate, or if I needed another specific file type like a BSP. For the player, I first had to get the artwork from Procreate into a PSB format using Photoshop, and then it was really just as simple as dragging it into Unity, and then I made custom animations using a skeletal mesh. I chose to use Procreate over Photoshop for all of my artwork because, as working on this alone in just 6 months really, I didn't have that much time, and if I ended up using Photoshop for the time that I did spend in Procreate, I don't think I would have made it this far. For my music, I ended up using GarageBand. It's also an iPad app and it's very lightweight and very easy to make 30-second loops of music for your games in it. I also did consider using larger software like Audacity, but I don't have much knowledge in sound design and it was extremely easy to use GarageBand. While I managed to complete this project, there are so many things coding alone that I would just change. If I could start again, I would like to focus less on the art and more on mechanics coding. There are definitely a lot of systems that could do with improving even though they work, just for efficiency and standard. Like the input system or keybinds. Changing both would not only make them more efficient, but make the feel of the character better, because I could move the character off axis input rather than button input.